Guys, welcome back to daily LeetCode solution video. I'm feeling a bit sick, so my voice is a bit low today. Sorry for that. Uh, from now onwards, before solving question or in order to choose question, we need to follow this step. First of all, what we need to do is we need to find the question, right? In order to solve the question, we need to find the question. For finding the question, what we are gonna do is we are gonna look at the topic of the question, and if we see that the question is manageable, then we will solve that question. Okay, and next step is we'll try to check whether we can study the topic or not, and if we can study or if it is within our capacity, then we'll try to solve it. Okay, so, so sorry, let's try to solve a medium difficulty question today. The question number is question number 15, and the title is threesome. Let's look at the topic. The topic is array, two pointers is sorting. Okay, I think I can manage this. Let's read the description of the question. Given an integer array norms, return all triplets norm I, norm j, and norm k, such that I is not equals to j, I is not equals to k, and j is not equals to k, and norms I plus norms j plus norm k equals to 0. Notice that the solution set must not contain duplicate triplets. Okay, so the input is -1, 0, 1, 2, -1, -4. Uh, so what we have to do is, I think, let's take the first array and try to form the logic for it. What we are given is -1, 0, 1, 2, -1, 0, -1, 0, 1, 2, -1 and -4, right? Yeah, it's -4. And our desired sum is 0. So as we can see, the length of the uh, okay, so the length is only up to 3000. We need three. Yeah, right. So what we can do is uh, we need to create a loop, and we need to first of all add these three number, and also check whether these number are uh, if any of these number are equal or not. If not equal, then we will add them, and if the sum is equals to 0, then we will add this array to our answer array, right? And in next step, we will um, instead of taking this, we will take this and try to solve this. For this, we will require I index, j index, and k index, and okay, I think we can do this. Let's first make a vector consisting of vector ending with int, vector int, and name it answer. And what we can do is for int I equals to 0, I is less than nonce dot size -1, I plus plus, and for the loop of j, what you can do is int j equals to I plus 1, j is less than nonce dot size Okay, so it should be equals to nums dot size minus 2. This should be equals to nums dot size minus 1, j plus plus. Then we will call another array, sorry, not array, another variable, k is equals to j plus 1. J is less than, sorry, nums dot size, nums, this should be k, and k plus plus. Okay, so what we have to check is first, if nums I equals nums j or nums I equals to nums k or nums I equals to sorry, not nums I, nums j equals to nums k. Okay, so instead of using equals to, what we can do is we can use not equals to, not equals to, and not equals to, and not equals to, right? So if nums I is not equals to norms I is not equals to norms k, and norms j is not equals to norms k, then what we have to do is we have to add norms I with norms j with norms k. And if their addition results to 0, then we will, okay, so we won't return anything. What we will do is we will uh, in each step we have to create a vector of int nature, named temp, whose size is equals to 3. And what we will do is we will uh, temp, temp 0 equals to norms I, temp 1 equals to norms j, not also norms j, and temp 2 equals to norms k. Instead of doing this, what we could have done is we could just use copy function in norms dot I comma nobs dot k comma temp dot begin, right? I guess that was the algorithm. And after inserting, what we have to do is we have to else dot push back. If I guess the function was push back, right? Push back, sorry, push back. Yeah. After the loop completes, we have to return the answer. Let's check the solution. So, Sorry. Minus 1, 0, 1. The answer should be correct. Okay, let's look. Minus 1, 0, 1, comma 0, 1, minus 1. But the solution is correct, I guess. Otherwise, it's showing mistake. It is clearly saying the order doesn't matter. Okay, so if the previous one is equals to, then we, okay. So what's happening here is we have already inserted minus 1, 0 in one combination. And here we can again see there is a combination of 0, 1 and minus 1, which is same. So our algorithm is adding that here, which we can't do as duplicate is not allowed. Yeah, duplicate replace. Okay, so it can contain duplicate number, but it can't contain duplicate replace. Okay, I got it. First, I thought that we couldn't contain duplicate numbers inside of same array. So instead of using this loop, we require new type of loop. So instead of using this, uh, select this one. I guess we okay. So if nums I, nums j, and nums k equals to 0, then we have to check. We have to also check whether the element are already contained by previous array, right? Or should we check that? Okay. How to eliminate same combination is they are not in same order, so we can't simply compare first index with first index, second index with second index. We have to compare the whole array with each other by sorting it. I guess that's how we should do it. So before pushing or before adding that array to our main answer array, what we can do is we can simply sort the temp, right? So each time temp will be sorted, so element will always be in ascending to descending order. After this, we have to check what we can do is for L, L equals to 0, L is less than. Okay, so next thing is we are, yeah, nums is first, so it works. What we need to do is less than our temp dot size, right? So if two array are already added, then its size should be equals to 2. Yeah, to L plus plus dot I plus plus L plus plus. Then after that, what we have to do is we have to compare is it is already sorted. What we have to do is we have to compare temp temp I0 is equals to temp I0 is equals to, sorry, not temp, it should be else. We are pushing it to answer else. If temp0 and else I1 equals to temp1 and else I2 equals to temp2. This condition is to check if, okay, so it shouldn't, yeah, it should be and as every element should be same. Yeah, not contain duplicate triplets. So if we simply put or not here, then it will work for all those cases where the triplets are not same. If triplets are not duplicate, then we can push it. Okay, so there is a case where ants might not have any element. In such case, we can simply do this. If answer doesn't have any sub-array, so we won't have any sub-array to compare. So we can simply push it. Otherwise, if there is even one sub-array, we have to compare it, but it will consume more time to compare. No, let's use function sort. There is a function sort, right? Okay. In order to use sort, what we have to do is temp0, comma, temp2. I forgot. What is sorry. Security typically occurs when some function or other algorithm require iterators to work with a container. And there is an issue with the type that are passed to this algorithm specifically. It seems like the error is due to an issue with the value type of the iterator, which in this case is being interpreted as code is passing into raw pointers with algorithm except iterators. Let's look at the solution. Okay, so it was team.begin thing. Yeah. So we need to use dot. Okay. Its temp has only 3 elements, so we can use temp.begin and temp.end. Yeah. I didn't knew about that temp.begin actually represent index. I thought it represent the first element. So I have to be careful about that too. It exceeded the memory limit, as I thought. So instead of doing this all, what we have to do is we have to go through this array linearly. We have to go this array linearly and compare these two. Then compare this. Sorry, I have to compare these three. Then compare these three. But it won't work like this. compare these three, then we have to compare these three, then we have to compare these three. Just sliding window method work? No, it won't work. If we use sliding window, first of all it will compare these three, then it will compare these three, then it will compare these three, then it will compare these three. Okay, so after that we would simply come here and compare this. But it's already compared. Sliding window only works when they are in continuous form. But we might have to compare this. Okay, so the solution is saying memory limit exceeded, not time limit. Okay. So we are using more memory than we actually need. We require the array. Yeah, each time we are creating a vector, so I guess it's consuming more memory. Can we delete the vector variable? Okay. Not vector variable, vector object. And delete vector. Yeah, I want to delete the entire vector object. Okay, so you can simply write delete, right? So this is the loop. Simply delete. But it only could delete. Okay, so it should be up pointer or it should be dynamical allocated. So instead of creating this again and again, what we could do is we could simply create it once and now we can use it multiple times. Simply the value will be overwritten and not and the vector won't get created again and again. Sorry. Yes, still memory limit is exceeded. We're creating ions answer vector and not a vector. So I can memory being yes. The two-pointer technique is a common technique with algorithm strategy, common computer science. involving array list. It involves using two pointer or instance to traverse the data structure in a particular manner, typically from opposite end or specific order to achieve the desired result effectively. Okay, so this is the algorithm which we use for solving fast, medium difficulty question. Yeah, that's the algorithm. So what we be able to solve this question using this, what we have to return answer, so we will require this answer vector anyway, and we need this temp, otherwise we won't be able to use this two-step technique. So is there any method where we could simply use non-signals in non-key without using temp? Let's see if we could simply add the element without adding the whole vector. Adding a single element, adding an object including custom type, pushback, pushback person, adding object. Okay, so we don't need an object. So it is creating the vector. Okay, so we can directly insert the value, right? Yeah, that's what I require. Instead of doing this, but we have to sort this. How can we sort? Let's see if there exists any function for sorting the elements. This is very sort. How can I do that? Yeah, I can do this, but I thought if there was a function, then it would have been easier. Okay, so the sort method won't work for us. Instead of using sort, we have to use brute force method and compare. We need temporary to write it. Sorry. Yeah, we could use sort. Okay, we need to use you need to check. We will arrange it in ascending order. So if norms I is greater than norms j, then we will swap norms I. Wait. It said we could use array, right? Yeah. Um, Sort, sort, stick, range, sort. Let's see. So we have two array plus one, array plus four. But what about using vector? Okay, so we can use plus. Okay, so it will work. But if we sort the element present inside of norms, then won't it disrupt the arrangement of the numbers? It will. Okay, so it won't work. Instead of sorting this step, if we try to sort this the number present inside of norms, then it will disrupt the uh, initial arrangement of the numbers and the loop won't work. However, what happens if we sort the whole element in first? Let's try that then. Minus 1, 0, minus 1, 0, 1, 2, minus 1, and 4. So if we sort it, then it will become minus 1, 0, 1, 2, and 4, right? So what we can do is uh, to compare this, and this. Okay, instead of doing this, what we can do is we can take the first element, we will take the second element, and we will take the last element. Okay, it won't work that way. We can go in our, we can use our simple algorithm, but as it is already sorted, so we can simply compare the element without having to go through all this. I guess it will work. So okay, we could we can simply remove this stem. What we can do is we can sort norms dot begin, comma norms dot end. If we do that, then all of the elements are sorted. So we won't have to sort anything now, as it is already sorted, and so we can compare individual element without doing anything, as the added element will always be in sorted order, right? So in this case, first of all, we'll compare minus 1 and 0, which is not our desired answer. We will compare minus 1 with 1, it's also not our desired answer. Next, we'll compare minus 1 and 2, which is our desired answer. And so it will be minus 1 and 2. As the initial size of array is 0, so we won't have to compare anything. Next, we will compare minus 1 with 4. It's not our desired answer. Now, next we'll compare minus 1, 0, and 1, which is our desired answer. To sort as minus 1, 0, and 1. We will compare minus 1, 0, and 2, which is not our desired answer. We will compare minus 1, 0, and 4, which is also not our desired answer. Next, we'll compare minus 1, minus 1, 0, and 1. It's our desired answer. However, as it is already in here, so we won't have to push it. Next, we'll compare minus 1, 0, and 2, minus 1, 0, and 4. It's not our desired answer. Next, we'll compare 0, 1, and 2, 0, 1, and 4. Not our desired answer. 0, 2, and 4, which is also not our desired answer. Right? Yeah, so if the sum is equals to 0 and answer size is equals to 0, then it will push. But if not, then we have to compare with individual and check if buffer overflow. Okay, so we don't have temp, so we can't use temp here. We need to use norms I, not norms I, norms, yeah, norms I. It's not temp, so we can't use temp 0, temp 1. Norms J and norms K. If the size only go up to the given size, so we want to have this step buffer overflow. Sorry, it buffer over. Okay, so it's getting buffer overflow. Is it getting? In the vector, then norms, if we use norms dot size, what size will be equal. Rows. Yeah, so it will return the number of rows. So in first case, okay, so I didn't put break here. That was my bad. The break should completely terminate this current iteration, right? So it's getting improper overflow. As we are not going above the limit, so why are we using I here? We should use L, not I. Now we are going to get number exceeded. Why is the number being exceeded? I'm only using I, J, K, and L, which are simply four variables, and I'm using a vector, 2D vector, which we actually require for returning the answer. We need I, J, K, and we also require L. Let's fill this solution, ChatGPT, and ask why is it showing memory exceeded. In the loop, we are comparing every trigger to the existing result in the else. Then if statement inside the sub is incorrect return is it will repeatedly add the same triplet multiple times due to the way it is structured. I am saying not right. If it is not equal, then only to push. You are comparing every triplet with the existing result. The if statement inside the enormous loop is incorrectly written, as it will repeatedly add the same triplet. I'm saying if all these elements are equal, and I'm adding not here, so it means not equal. So not equal should mean that these elements are not equal. If I is less greater than 0 and okay, so you could actually do that. So why is it not comparing the case where, okay, so if we simply, is- sorry, is we have sorted, so if we simply skip the duplicate element, then get, we won't have to check it, right? Let's try it then. My voice is getting so deep right now. Uh, so first of all, we'll compare minus 1 and 2, which is our answer. Next, minus 1, 0 and 1. So if we simply, okay, in the correct answer, 1 is minus 1, 2. Next is minus 1, 0 and 1. So in next case, if these two elements are the same, then I can simply skip it, right? So if I simply skip it, then I'll go here. So there won't be the possibility of getting duplicate. So I won't need this at all. And I can simply do this. What we can do is, if norms I equals to norms I plus 1, if these elements are equal, I can simply continue. So if I simply continue, then the duplicate element will be, uh, so we'll go from minus 1 to 1. So if they have duplicate, then what will happen? Suppose we add one additional element here, 1, okay, 1, 2, and 4, right? So if this happens, should we check it for B2? Is okay, so let's try this first. Output 0. Okay, we are using temp here, which we shouldn't do. And next, we have to push like norms I, comma, norms J, comma, norms K. Let's check whether this is correct or not. Yeah, that is issue. But you need to ensure that no duplicate stickers are added to else. So now it's not adding. So now it is not adding minus 1 and 2. Why is it not adding? Okay. So we actually had answer minus 1 and 2. So what we have to do is, if I is not equals to 0, So it will check if it is first index or not. If it is not first index, then what we are going to do is if norms I equals to norms I minus 1 is equal, then we will use continue and run it. Okay, let's submit it. Let's hope we won't get any. Okay, we got a wrong answer. But this should solve this, right? Norms I equals to, so you do it same for J in K2. Not that would be nice, I guess. Let's see. So in case of 4-0, what is happening is, first of all, 0, 0, 0 has already gone. Now, uh, as these two are same, so our loop should simply iterate to next, and as these two are same, our loop should simply iterate to next. So we shouldn't get any error. Okay, so we have to check it for J2 and K2. As in first iteration, these three are being added. In next iteration, this and this is being added. But we have to check if this is equals to this, then we should not add it, right? Then for J2, if this and this are equal, then the case will be same. Yeah. But in case of J, this should not be equals to I plus 1, right? If it's the first index, then we shouldn't compare it with the minus 1 index. If it is already then I plus 1, then we can compare it. Similarly for K, should be not equals to J plus 1, then K should be compared to K minus 1. Continue. I should have first checked it for this condition, then I should have submitted what I actually directly submitted it. And now I got time limit extended. Damn. So I need to actually learn this algorithm now. Before trying it, I should learn this algorithm, pointer algorithm. Well, try it. While left is less than right, int sum equals to left plus right. If sum is less than target, okay, as it is already sorted. Okay, so I understood the algorithm. Now let's write. As we have already sorted, and we have to compare three number. So we can't only use left and right. We need to use I too. In time less than nonce dot size minus nonce dot size minus 2 I plus plus. So our we have three pointers or three indices. First indices will move linearly, whereas these next two will move towards each other in this way. Okay. Sorry. So what we have to do is, first of all, we need left, which should be equals to 1 first, and right, which should be equals to nonce dot size minus 1. What we will do is, we will check if, first of all, let's create another variable name sum. What we'll do is, sum equals to nonce I plus nonce left plus nonce right. And we'll compare it with sum. If sum equals to 0, and then what we'll do is we will s dot push back nonce I comma nonce j comma nonce k. So and else if sum is greater than 0, which means that our sum is greater than 0, it means that we have to decrease the right index. As we know, in sorted array, if we're adding minus 1, and 4, and the answer is not equals to 0, then we need to lower the index of right side. Else if sum is less than 0, okay, so we need another loop here. While left is less than right, okay, so left plus plus. So if sum is 0 and our answer is minus 1, then what we have to do is we have to increase. Then we have to check another case too. If I is not equals to 0, if Okay, so yeah, if I is not equals to 0 and norms I equals to norms I plus 1, then simply continue. But we'll get error in 0, 0, 0, right? Is info 0 or I currently I currently 0, our left is 1 and right is 3, right? So we'll add this and this. We'll add this and this, which is 0. So it will be pushed back. In next case, our uh, is left is still less than right. So, okay, I didn't consider about that. What we have to consider too is if sum is 0, then neither right is increasing nor left is increasing. So nothing possible is going to happen. Yeah. So we have to think account of for that too. As we can see, if sum is equals to 0, so simply answer will be pushed back. But neither right nor left will be increased. So in next loop too, same right and left index will be used. So we need to change the right left index here. Instead of doing that, we could uh, bring right index here too and add these 3. After that, we need to break the loop. Let's look what the solution is down here. Left equals to solve, solve 0, then push back. Okay, so even though the solve is, we have to do this right, while left is less than right and non equals to left plus 1, plus plus. Okay, okay, I got it. So what we have to do is, in this case too, we have to check if left is not if we need to use while. Is it can add. This case can occur multiple times while left is less than right, while left is less than right, and if norms left equals to norms left plus 1, that is left plus equals to 2. If left and next left are equal, then won't all the possible scenario be same? So in case of 0, 0, 0, a sum is equal. So left is 1 and right is 3, right? And as left is equals to right. So it is saying to move one step up. And as right is equals to right minus 1, it is saying to go here. But if there were to be 5, 0, 5, 0, and as this will, I told 5, 0, this will come here, and this will come here. And still the sum will be equal, and the answer will be 0. So what we have to do is we have to move 2 steps forward. Okay, so we are using while. Okay, so as there is while, so what we can simply do is we'll compare this with this, we'll compare this with this. Why is it adding only one time? It should be adding 2 times, right? As uh, if left and left one is equal, then it is only adding one time, and then it will go here. But the value will be same. As we need to have a duplicate value, the value should actually go here. And again compare this value with this value. If this value is the same too, we need to opt here. Yeah, loss equals to 2. And if not, yeah, if norms right equals to norms right minus 1, then right minus equals to 2. And again, we have 2 left plus plus and right minus minus. Yeah, I don't know if it will open up. Okay, so it shouldn't be I, it should be right, and it should be left. Okay, so if I'm trying to add in a string order, it should be left and it should be right. 5, 37, it is pointing for this, and it is pointing for the whole for loop. Okay, so I haven't written anything. And return as expected output. What is happening here? Let's see. Uh, minus 1, minus 1, 0, 1, 2, and 4, right? First of all, first of all, our I is at 0, left is at 1, and right is at 1, 2, 3, 4, 5, 6. So it is at 5. So we are adding these three, right? We are adding these three, and as the sum is not equal, so sum is not equal, and the sum is equal to 2, so it is greater. So we are decreasing the value of right by minus 1. So the right becomes now 4, and it is pointing in 2. right? Yeah, as if sum is greater, here we are adding sum is not equals to 0, so it will come here, sum is greater than 0, the sum is greater than 0, so right minus minus, so right index is going from 5 to 4, so it is a 2, it is again, so it will come again here, is left is still smaller than right, so it will add these 3 again, which is equals to minus 1 and 2, which is equals to 0, which is equals to 0. So the answer will be, so the answer will be pushed. That should be pushed. After that, is left is still right, less than right. So left is being compared with left plus 1, which is not equal, and right is being compared with right minus 1, which is not equal. So again, left is left increases by 1, it becomes 2, and right decreases by 1, it becomes 1. So we are comparing minus 1, 0, and 1, which is equal. So as it showing, not showing anything. Incorrect initialization of pointer left should be set for I iteration in your code. Okay, yeah, actually, that is correct. Instead of doing this, what I need to do is I can create left and right here, but left should always be equals to I plus 1, but right is always same, right? And not size minus 1. That's what I did. Not size minus 1. Yeah. Minus 1. Next figure is skipping duplicate non-I. However, these checks should be performed at the beginning of the loop for each I to avoid duplicate the starting element of the template. But if we do that, then we won't get minus 1, and 2, right? As if one is, if we compare 1 with 1, then it will go simply here. And it will only compare other possibilities and it won't compare minus 1 and 2. Incorrect duplicate skip. In your code, when you find a valid triplet, you attempt to skip duplicate from left and right pointer. However, you are incorrectly skipping when a duplicate is found. Okay, I will try to understand why it is only adding one. We subtracting by 1 year later. First of all, let's get this code correct. Okay, so the time limit exceeded. Using same logic as here. Okay, let's use this cell. It worked. I'm doing this here, this same. I'm doing this same too. Doing this same too. This also same. So I getting time limit exceeded. I is greater than 0. I'm doing this, doing the same thing, right? I could have done this too. Not equals to 0. I could write greater than 0. That doesn't make any difference in our case, as indices will always be positive. Equals to nonce I minus 1. Will continue as the norm size remains same. So yeah, right is okay, okay. So each time the size of the right is decreasing and not so for dot size minus 1. I'm doing the same. So I guess that was the reason for it. Mistake or not. Yeah, it is again same time limit exceeded. While left is less than right. Okay, okay. So instead of doing this for both, what we can do is while left is less than right, if norms left equals to norms left plus 1, left plus plus, and actually we are already incrementing it with 1, so it, at the end it is being increment with 2, right? So my logic was correct, but I wasn't looking at the question correctly. In year 2, while left is less than right, if norms left, not left, norms right equals to norms right minus 1, right minus minus. Yeah, instead of using if here, we can use and simply remove this. Plus, okay, Let's submit. Let's submit it. I know we are looking at a lot of solution and trying to solve it, but I think what we are currently doing is we are learning various algorithms. Like today we learned about two pointer two pointer algorithm, right? And we also learned two pointer algorithm for three different elements. And we also learned about we can directly push back element in this way. And I also learned about doubly linked list today, but I couldn't explain it here as the video is already 2 hours and 21 minutes long. So I will leave the video of today in this point. And okay, so that's it for today. I thank you for watching, and I will see you tomorrow. And I hope tomorrow we'll be able to solve question a bit faster, and also I'll try to explain double linked list tomorrow. Thank you.